All right, let's jump in and see how y'all are doing today. Everybody got a calculator? If not, you can look on. I think there's still a couple left over here. And yeah, there's still donuts left too. Smart enough to get into NHS, but not smart enough to remember when the meetings are. All right? Too many donuts. Was it a pop meeting? Was it for current members? Oh, did they? Okay. Yeah, like, right. Oh, good question. Yeah. Do I want it in degrees or radians? We'll talk about that. All right, so let's look at this. It says convert theta equals 7 pi fifths 2 degrees. Now, when you look at that angle, how do you know that 7 pi fifths is in radians? Yes, because there's no degree bubble, right? If I had said 7 pi fifths degrees, then that would just be an angle in degrees, and 7 pi fifths is just like 21 divided by 5-ish, right? But because there's no degree bubble in the context of an angle, it's in radians. It's also helpful context clues when it says to convert 2 degrees. Like, oh, it must not be in degrees. Okay. And then it says to draw it into standard position and find the reference angle. So here's the conversion, right? 7 pi fifths. If you want, you can put radians or rads or rad, whatever you want. And you can kind of put it in the numerator. Then we're going to multiply by a conversion factor. You want radians to divide out, and you want degrees to appear. So what is that? 180 degrees in how many radians? Pi, right. So there's your conversion factor. And now we can look to see what happens here. Your pi's divide out, right? And now some of y'all picked up the calculator, right? 7 times 180 divided by 5. You could do that. Or you could do, without a calculator, 180 divided by 5. That would be what? 36, right? So it's 7 times 36 degrees. And then you can work that out. That's going to be 252 degrees. There you go. Now, you don't have to do that. You'll have a calculator. I know we live in an age of technology, right? But mental math is still a very, very valuable skill. So 7 times 180, and then we'll divide that by 5. And notice that we didn't even get the pi's involved. Why? They divided out. Right, good. So there it is, 252. So another way to get the same right answer. Now let's go ahead and draw it in standard form. So y-axis, x-axis, 252 is going to terminate in what quadrant? Right over there. Yeah, there you go. And we'll call that theta. And the reference angle, let's identify that. The reference angle is this little red guy right here. It's that small positive acute angle between that terminal ray and the x-axis. So let's write out how we're going to find it. Okay, theta ref will equal, in degrees, we'll do it in degrees, that's how we've been doing it. How do we do that? Yeah, 252 degrees, we've gone past 180 minus 180 degrees, and of course you don't need the calculator for that, do you? It's 28. Right, now you better get a calculator out if you're going to call that 28, right? That's going to be 72, yeah. And don't forget that anytime you're working with degrees, on your final answer, I'm not going to be too picky on your intermediate calculations, but on your final answer, you better have the units of degrebles or degrees on there, okay? Otherwise, I'm going to say, are you talking about radians, 72 radians? Okay, now, is there a way that we could have determined that quadrant 3, and the reference angle without converting it to degrees? And the answer is not that I know of. Okay. Here's traditionally what we're going to do. If I give you an angle that starts in radians and I ask you to find the reference angle, that means I want the reference angle also in radians. Same thing if I start it in degrees, I want it in degrees. Now this one I asked you to convert to degrees, so we're not normally going to do that. In fact, we are going to leave degrees behind completely. We are not even going to work with degrees anymore. If you say degrees in this class after a few more days of in-class notes, I'm going to assume you're talking about the weather, okay? We are going to go exclusively to radians. So you need to start thinking in terms of radians, all right? So let me help you make that transition. Let us draw, well, we can use the same picture that we had over here. 0 degrees right here is also the same as 0 radians. We haven't started rotating at all. We know up here that 90 degrees, we saw that yesterday, was pi halves. Of course, 180 degrees is pi. 270 degrees, do you remember what that was from yesterday in radians? 3 pi halves, 1.5. And then, of course, coming all the way around coterminal with 0, we get 360 degrees, comma, also known as 2 pi. Okay? So these are called your quadrantal angles. Quadrantal angles. They terminate on an x or y axis. Okay? So technically there is no reference angle. If an angle terminates on the x-axis, the reference angle is 0. And if an angle terminates on the y-axis, the reference angle is 90 degrees. Okay? Neither one of those are acute. So these are kind of the exceptions. So here's an easy way to do it. If I ask you again for theta equals 7 pi fifths, this is the easiest way that I have come across to help students determine where this thing is going to live without converting it to degrees. Come over here to pi, right? We have donuts this morning, but have you ever just been handed a pie? Boy, that's another like blessed day, right? Whatever we are using in the denominator right here, fifths, we want to cut that pie into that many pieces, right? Okay? So if someone handed you a pie and it was uncut, and we're trying to do something pi fifths, okay, if you then cut that pie into 5 pieces and you ate the whole pie, I don't blame you. How many pieces did you eat? Too much. You ate 5 pi fifths, right? That's pretty easy, right? Pi is also known as 5 pi fifths. Agreed? I'm just multiplying by 5 over 5. If I had cut it into 6s, then I would call pi 6 pi 6. If I cut it into 12 pieces, I would call pi 12 pi 12s. Got it? Once you get pi figured out, it's 5 pi fifths. Take half of the numerator. What's half of 5? 2.5. So this would be 2.5 pi fifths. And that's the money unit right there. Because now every time you go to another 90 degrees, you're counting by another 2.5 pi fifths, right? So we have essentially 0 pi fifths at 0. We got 2.5 pi fifths, then 5 pi fifths. What would 3 pi halves be? What's another 2.5 plus 5? 7.5 pi fifths. Okay, so you see what I did? I got my pi, and then I cut it in half. And that gave me 2.5. And now I know that every time I go to another 90 degrees, all I got to do is add another 2.5 to the numerator. So this is 7.5 pi fifths. And we'll keep going. If you add 2.5 to 7.5, what do you get? 10. So this would be 10 pi fifths. What's 10 divided by 5? 2. So that's equivalent to 2 pi. Okay? So once you have your quadrantal angles now set up in terms of fifths, now it's a piece of cake. Boy, all kinds of pastries this morning. Okay? We want to know where, 7 pi fifths lives, huh? So notice that 7 falls between 5 and 7.5. Agree? So I know it's going to terminate and fall somewhere in there. I'm not really concerned where. I just know it's going to fall right there, 7 pi fifths. Okay? So that's how we can figure out where it lives. Now, in terms of the reference angle, you're going to like this. This is going to be a lot easier than using the calculator for degrees. For degrees, we did 252 minus 180. Look how easy it is here. I've gone past pi, which is 5 pi fifths, all the way to 7 pi fifths. How many pi fifths did I go past 5 to get to 7? 2. In other words, what's 7 minus 5? 2, right? So the reference angle right there is 2 pi fifths. It's that easy. The x-axis, 180, is 5 pi fifths, and I went to 7 pi fifths, which is 2 more pi fifths. Okay? Guess what 2 pi fifths is if you convert it to degrees? 72. Yeah. So it's going to be a little bit more work for you in the beginning, but you're not even going to really need your calculator in the end because you're going to just be working with fractions. And we had a lot of practice with that in the beginning of the year, okay? We're just going to be working with fractions of pi, all right? Pi. It's always better when you think about money and food. It helps you remember things. So we're going to be thinking about pi. Yeah.
So, like, if your denominator was, like, 7,
Uh-huh.
it would be, like, 7 pi 7, but always on that, like, 180 mark.
Right. Exactly. Let's do another one. Let's do I don't know. Let's do go ahead and figure out where 12 you said sevenths, I'll do it. Where's 12 pi sevenths? Go ahead and sketch 12 pi sevenths and figure out the reference angle. And try not to convert it to degrees. In fact, I forbid you to convert it to degrees. If you do that, you don't get another donut. What'd you get? Need more time? I know. I'm still working on that. Appropriate wait time. They teach you that in teaching school. It's called appropriate wait time. You ask the students a question, and there's appropriate length of time you're supposed to wait before you elicit answers. I'm no good at that. I want to know right away. I'm impatient. Yeah. Do you have to do the math? What do you mean the math?
Like what we did on the warm-up first.
Convert it to degrees? No. We're starting a transition today away from degrees. We have to be able to work with unitless measures of rotation for our applications. Yep, that's right. And then you would just draw where right, so that's where it lands.
Okay, and then that's your reference.
So what's the size of that?
1.
No.
Wait, is it?
Go all the way around to your x-axis.
Right. Is it right here?
You would add another 3.5 to there to get all the way back to here.
Yeah.
Which would be what? It'd be 14. Remember that a pi, like if someone hands you a pi, that's all the way around, right? It's a round pi. But on the unit circle, pi is only halfway around, okay? So let's do this. 12 pi sevenths. We are cutting it into sevenths. So that's the magic number, 7. So I'm going to come over here to pi. I always know where pi is. It's over here, that 180. That's the same as 7 pi sevenths. Yes, yes? Piece of cake, piece of pie. What's half of 7? 3.5. So up here is 3.5 pi sevenths. Now I can count by 3.5. So 3.5 pi sevenths plus 3.5 gives me 7 pi sevenths plus another 3.5 gives me 10.5 pi sevenths. And go all the way around. What's 10.5 plus 3.5? 14 pi sevenths. And that should equal 2 pi, does it? It does. So now I have my quadrantal angles partitioned in terms of sevenths, and now I can easily figure out where 12 lives. 12 is going to be between 10.5 and 14, right? So it's going to go all the way around here, somewhere, boom, in quadrant 4. Go ahead and write 12 pi sevenths at the end of your terminal ray. That's fine. You could do that. And now the reference angle is right here. And look how easy it is. How far do I need to go from 12 pi sevenths to get to the x-axis, which is 14 pi sevenths? 2 pi sevenths. There you go. The reference angle is 2 pi sevenths. And we did that all without a calculator. We're conserving batteries. We're conserving energy. We're actually storing up energy by eating donuts. Okay? Yeah. But actually, using your mind burns more calories than using your body. I don't know if that's true or not, but it sounds good. Right? Yeah, it sounds as if smart. Yeah. All right, so that's not a big deal anymore, right? In fact, that's kind of fun. That's kind of fun, right? Okay, so let's go ahead and finish this out down here. We're back to the notes. That was deviating from the notes. Throw on example 8. Let's go ahead and convert 30 degrees to radians, okay? Now, Let's do it without multiplying by pi over 180, because we've done that enough already. If 60 degrees is pi thirds, what should 30 degrees be? Well, 30 is half of 60. So if 60 is pi thirds, yeah, what's half of pi thirds? Pi 6. Very good. 30 degrees is pi 6. 15 degrees. Whoa, well, if 15 is half of 30, then half of pi 6 is pi 12. Yeah. Fun. Friday. 45 degrees. Whoa. Okay. We could convert it. We can multiply by pi over 180. But how many 15s are in 45? 3. So 45 should be 3 pi 12ths, right? But that simplifies to what? Pi fourths. Yes. Well, that makes sense, because 45 is also half of 90, right? And 90 we know is pi halves. Half of pi halves is pi fourths. So there's lots of different ways you can get there. Pi fourths. Negative 175.4. Ooh, I don't think we're going to be able to do this one without converting it the old-fashioned way. So let's put that over 1 and multiply by 180 over pi, right? Very good. This would be someone who's just like rolling the coin. They're rolling the coin. And then hoping the coin, once it stops rolling, flips over onto heads or tails. And they're just assigning one of the conversion factors as heads and the other one as tails. And then they're just going for it because they have no idea what they're doing. Okay, I'm going to quit talking about that. That's the wrong conversion factor. That would be 180 degrees over pi radians. Your degrees divide out. And so now it's time to pick up the calculator. So remember, we want pi visible in our answer. So all we got to do is go negative 175, negative 175.4. And then we'll divide it by 180. All right. Now, we could write that down, negative 0.97444444 pi, right? In fact, let me do that, negative 0.974 pi. So looking at that, that would be an acceptable answer. But can we get a better looking answer? This looks like it's a repeating decimal, does it not? Yeah, and remember, repeating decimals or terminating decimals are rational numbers, which means they can be expressed as a ratio of two, what? Integers. Yeah, integers. Okay, so all we have to do is hit the math button. So I did this too quickly yesterday. Some people forgot where this is. If you hit the math button right here, see where the math is? Hit math, and then it's number 1. So you just hit enter. And boom. Whoa! So there's a better looking number. Negative 877 pi 900ths. And that's what you write down. That's more exact. There's no rounding or, chopping off, truncating. Okay? Hey, let's figure where that guy lives. Forget it was negative 1. I don't remember what it was in degrees. I don't remember. Let's just look at that radian. Where in the heck would that live? Well, we're taking the pi and cutting it into 900 pieces. Wow, you need a sharp knife for that, right? So over here at pi, that's going to be now not 900 over pi, but negative 900 pi over 900, right? So if we're rotating in the negative clockwise direction, what's half of 900? 450. So this would be negative 450 pi 900ths. And now we know for sure that 877 falls between 450 and 900, so it would live over here, somewhere in here, right? That would be negative 877 pi 900ths. It just started off as negative. It was a negative angle to begin with. Yeah. So, can we figure out the reference angle now pretty easily? Yeah, the reference angle is this measure right here. How far do we have to go to get from 877 to 900? 23 pi 900ths. Is it positive or negative 23? Positive, because reference angles are always positive. Good. So the reference angle is 23 pi 900ths. See how easy it is with fractions of pi? Once you learn what we're doing, it's like, man, I never knew I'd have this much fun in a math class, right? But anyway, Notability updated, and now you can make your own colors, right? And that is fun. That is fun. Okay, so that was a little bonus activity on the end of I. Okay, how about this one? 5 5/4. Is that in degrees or radians? Degrees. How do we know? That grumble. There it is. Okay. So we need to convert that by multiplying by 180 over pi, correct? No, that's incorrect. Good. Okay. So it's pi over 180. And again, make sure, if you're not sure, make sure that your units divide out. Now, do the pi's divide out? No. But they do multiply together if you want. You can call it pi times pi, which is pi squared. And then you got 5 divided by 4 divided by 180. So notice you got a factor of 4 and 180 in the denominator. The easiest way to type that in is just go 5 divided by 4 divided by 180. If it's a factor in the denominator, just divide by it. And you get that. So again, you can write it like that, 0.006 or 007. But again, it looks like it's a repeating decimal. So the better version would be math, enter. And there you go, 1/144. Yeah, so the pi squared is still there. So pi squared times 1 is pi squared over 144. Okay. That one's not going to be as easy to determine where it lives because it's not a multiple of pi, it's a multiple of pi squared. Okay. All righty. Comments or questions on that? Good times? Let's do one other thing that I kind of slipped up on way over here. We know that 1 radian, remember, is if you take the length of a radius and you go out along the perimeter, the circumference, one length of the radius, this central angle is theta, and it's 1 radian. How many degrees is 1 radian? 1 radian is equal to how many degrees? Can you tell me? Less than 60. Very good. How do you know that? Yeah, there's still some left over when you fit 6 of them in there. So a 6 of 360 is 60, so it has to be a little bit less than 60. Yeah. Can we figure out the approximation to 3 decimals? Sure we can. Let's convert it. We got 1 radian, put it over 1. Now we got to get rid of radians. And again, radians is not a unit, it's just a description. But it's helpful to have it written there so that you have something to divide out. And we want degrees to appear. What is the conversion factor? 180 over pi. So really, it's just 180 divided by pi. 180 divided by pi. So it's about, you're right, exactly a little bit less than 60. 57.295 or 296 degrees. There you go. So it's kind of nice to know what the approximate value of 1 radian is. It's about 57.295. Yeah. You know what else is nice? Well, there's lots of nice things. But you know what? We as Americans can't have nice things, apparently. Did you hear what happened in Joshua Tree State Park? You know we're under a federal shutdown right now. Joshua Tree State Park is a state park that has Joshua trees in it. You know what a Joshua tree is? You could Google it. They're on the cover of U2's Joshua Tree album. But they're like on the verge of being endangered. But anyway, Joshua Tree State Park is a sanctuary for Joshua trees, where Joshua trees can roam freely over the plain. It's the size of Delaware. That's huge, okay? Well, the parks are closed, but they're not prohibiting people from entering, okay, during the shutdown. So they're unmanned. Now, I think Joshua Tree State Park has like 3 rangers that are still there, but 3 rangers to cover something the size of Delaware, not very easy to do. So the bottom line is people were going into the federal parks without paying the admission because there's no one there to collect the fees, and they were cutting down Joshua trees and graffitiing the place. They were destroying Joshua trees, cutting them down. So we can't have nice things. I don't know. What would compel someone to do that? To go in and destroy those trees?
They feel bad about themselves.
And that makes them feel better if they feel bad about themselves? I don't know. I mean, you're making something up. I would only make something up because I can't imagine why someone would go in there. No, see, here's the thing. They're not cutting down the trees and taking them for the black market. They're just destroying them and they're leaving them there. Yeah. They're doing it just for the sake of killing Joshua trees, cutting them down. So anyway, I read about that yesterday and I was just like, America, not our proudest moment, right? That's not what Teddy Roosevelt had in mind when he said, let's make sanctuaries for these things in America. Okay. Anyway, I don't know how that came up, but yeah, whatever. All right. Any other stories to share? Oh, I said what else is nice. Well, yeah, I'll get back to that later. Let's go to example 9. Example 9. Example 9. Okay, so now on example 9, we're going the other direction. All right? We're planting Joshua trees instead of cutting them down. Oh, man, yeah. There's a lot of, citizen volunteers that are in the parks trying to keep bad guys out. And there's one veteran that spent $5,000 of his own money to go in there and clean up all the graffiti. Yeah, so, yeah, good guy. All right, so 5 5/4, that is degrees or radians? Radians, no degree. So we need to multiply by 180 degrees over pi. Yeah, now, you don't have to put rads, but you certainly can. But if your angle in radians has pi visible in it, like we prefer, it's really nice because what happens with your pi's? They divide out. So now you can just type it into your calculator. 180 divided by 4 times 5. Or if you remember, pi fourths was 45. So if you have 5/45s, you end up with 225 degrees. Okay, 225. Now this is going to be one of those angles on the infamous unit circle that you're going to have to memorize. 5 5/4 is it's on the unit circle. Now, where does 5 5/4 live? Well, we know where 225 is, but remember pi then would be 4 5/4, and so half of that is 2. So if we count by 2s, 2, 4, 6, 8, who do we appreciate? Not the people that are destroying Joshua Tree State Park. But where does 5 live? Well, it lives somewhere in here between 4 and 6, right?
Why did you put 8 on the bottom?
I don't know, because I was getting angry about those. Okay, I'm going to focus on math. Bless you. Bless you. What's the reference? Bless you. What's the reference angle? 1 pi/4. Right, 1 pi/4, or just pi/4. So pi/4 is a 45-degree angle. So this is a 45-degree reference angle. So just kind of alluding to why it's important, remember in geometry, you learned all your special angles, your 30, 60, 90, right triangle, and then your 45, 45, 90. If your reference angle is 45 degrees or pi/4, when we drop a perpendicular from anywhere on the terminal ray to the x-axis, we get what's called a reference triangle. A reference triangle, and this angle is 45 degrees. And so remember, SOHCAHTOA gave us the ratios of 2 of the 3 sides. SOHCAHTOA, right? So anyway, there you go. 11 pi/6. Go ahead and convert that one on your own. See what you get. Pi's divide out. Again, however you want to do it. You want to do 180 divided by 6 first, then times 11, or 11 divided by 6 times 180, or 11 times 180 divided by 6. You should get 330 degrees. Now, let's see if we can figure out where 11 pi/6 lives without thinking of it as 330 degrees. This would be pi, which would be 6 pi/6. Half of 6 is 3, right? So we're counting by 3 pi/6. So this would be 3 pi/6, 6 pi/6, 9 pi/6, and 12 pi/6. Okay? So where would 11 be? In the fourth quadrant, right here, 11 pi/6. What's the reference angle? How far to get from 11 to 12? 1 pi 6. So the reference angle is 1 pi 6. And if you remember, 1 pi 6 from earlier is 30 degrees. So this is a 30-degree reference angle right there. So if we were to drop a perp, we would make what's called, again, a reference triangle, and you would have a 30-degree reference angle like you did in geometry, or 30, 60, 90. So 11 pi 6 is another one you're going to memorize, okay? All right, 2 pi thirds. Ugh. I'm thinking of those guys again. Turds. Cutting down Joshua trees. All right, go ahead and convert this one on your own. I'm not even going to show the work because I know y'all know how to do it. Here's a Joshua tree in its prime. I mean, they're not the prettiest things, but still, they're people too. And then here's what people are doing. Yeah, what's that? Oh, yeah, I mean, well, when I say cut them down, I'm not sure if they're using chainsaws or they're just ramming them with their vehicles. But, yeah, here's another one, see? They're just, I mean, they're leaving them right there. Yeah, they are. But still, right? It looks like a desert, very arid. Yeah, it's very Joshua Tree State Park. Ooh, let's read about it. Government shutdown. Southern California. Yeah, look how pretty that is, right? Right? You climb those rocks, you're like, hey, look, there's a tree. Yeah, they're I think they belong to the cacti family. Yeah. Anyway, you can read this. They're creating illegal roads, so they're driving like where they're not supposed to. You know, it's kind of frustrating. They're just having fun. I know. But, you know, when you do that without respect for law and order, that's called chaos, right? And incivility, so whatever. What'd you get for 2 pi thirds? 120 degrees. Good. 2 pi thirds would live in quadrant 2, of course, because that's where 120 is. But again, here's why. Pi would be 3 pi thirds. Half of that is 1.5 pi thirds. And then 2 would fall between 1.5 and 3. So it's going to be somewhere over here. That would be 2 pi thirds. What would the reference angle be in radians? How far from 2 pi thirds to 3 pi thirds? 1 pi thirds. The reference angle is 1 pi thirds. And pi thirds is 60 degrees. So this is one you're going to memorize. It's a 60 degree or pi thirds reference angle. All right? Very good. Now 7 pi fifths is not one we're going to memorize. Go ahead and convert that one. Did we already do this one? I'm having deja vu. It might have just been from the last 19 years when I've taught this, but I don't think so. Did I do this in the warm-up? Yep. Yeah, I did. Well, you know, the good thing about math is we should get the same answer. Yay. There you go. 252. 252. Okay. 1.346. Ruh-roh. Degrees or radians? It's radians. How do you know? There's no degree bubble. So just because it has pi in it doesn't mean it's in radians. You really are looking for, in the context of an angle, does it have a degrubble? Does it not have a degrubble? There's no pi visible here, which means pi is multiplied into the answer. What quadrant does 1.346 live in? We can't break this one up into pi's. But we do know that 1 radian, remember, is about 57 degrees. 2 radians would put us about right here. That's 2 lengths of the radii. So where would 1.346 be? It should be in quadrant 1, right? It's a little bit more than 1 length of a radius wrapped around, okay? Now, here's what I was saying earlier is good to know. We know this is pi halves, yes? That's 90 degrees. It's pi halves. Pi halves, if you type that into your calculator, it's like 3.14 divided by 2. It's approximately like 1.5 or 1.57. That's good to know. It's kind of good to know because you're not always going to have pi visible in your answer. So 1.346 falls between 0 and 1.57. So it does terminate in quadrant 1. So that's an acute angle in radians. So how would we convert that to degrees? Multiply by what? Yeah, again, 180 over pi. Now here's the thing. There are no pi's to divide out. So we just type it in. We'll just use pi as a number. So 1.346 times 180. And then when you divide by pi, use the pi that's pre-programmed in your calculator. Don't just type in 3.14. It's the second caret, okay? And then you get an acute angle, as we were anticipating, 77.120 degrees. Do we need that third decimal since it's a 0? Can we leave it off? Yeah, we need it. Good. It's part of the accuracy. It's not a terminating decimal. So there you go. Okay? All right, so let's go ahead and finish doing what we were just doing, but it's nice to know. That's 0 radians if they don't have pi in it. 0 radians. We know this is pi halves, which you said is about 1.57. Of course, we know pi radians is about 3.14. We even know all the way around 2 pi is about 6.28. But this one we probably need to figure out. What is 3 pi halves as a decimal? Just kind of helpful to know. Let's see. 3 pi divided by 2. 4.71? 4.7? That's good enough. 4.7-ish. If you want to think about it as 4.7-ish. I'll even write that down. Okay. So again, not required that you know that, but you're not always going to get an angle in radians that has pi visible. When you do, you get excited. You salivate because now it's like, yay, we're cutting pi's up into pieces and all that stuff. But sometimes you can just get a decimal version, and you need to know where it lives. So if it's between 0 and 1.57, it's in quadrant 1. If it's between 1.57 and 3.1, it's in 2, so on and so forth, okay? All right. Any other comments or questions before we get into the real fun, which is catching those bad guys and administering our own vigilante justice? No. If you do that, you're no better than those guys. We live in a democracy. There's a system. Okay? All right. You know, some people have been like on death row for like 20 or 30 years. Wow, that's like... What's that? Yeah, I don't know. I mean, I don't know. But anyway, for each of the following angles, theta, find the coterminal angles such that alpha, find the coterminal angles alpha that live between 0 and 2 pi. Now, 0 and 2 pi is kind of like what we did before with degrees between 0 and 360. That means within one positive rotation. Okay? Then find the reference angle. So here we go. Just like we were doing on the quiz with the big angle, we're doing it with big angles, but now it's not with degrees, but radians. Okay. Now, remember for degrees, if I gave you a big angle, we would divide by 360, get rid of the integer part, and then remultiply by that same number, 360. We're going to do something similar to that, but we can't use 360 because we're in radians, not degrees. So here's what we're going to do. This is 46,365 pi sevenths. Do you think that's more than one rotation? Yeah. Let's see. One rotation would be actually how many pi sevenths? 14. Okay. How can you get that so quickly? If you're counting by sevenths, just double the denominator, right? That tells you how many of those pi sevenths you need in one rotation. Okay. So 2 pi, which is one rotation, is the same as 14 pi sevenths. We are not going to even worry then about the pi sevenths. Okay? Instead, we're going to look at the coefficient of pi sevenths, the 46,365. And here's what we're going to do. Just like before, we're going to take that number, 46,365, but now we're going to divide it not by 360, but by the number of pi sevenths in one rotation, which is what? 14. Okay? So essentially, you're dividing that number by twice the denominator. All right, let's see what we get. 4, 6, 3, 6, 5. That's how many of those pi sevenths we have. If we divide out multiples of 14, which are full rotations, boom, that gives us the number of rotations. That rotates 3,311 times. Just like before, we want to get rid of the whole number, 3311, and hit enter. That's the fraction of one rotation. Now we're going to turn around and remultiply, just like we did before, that number by 14. It's always the same number you divide it by, okay? Whether it's 360 for degrees or this one's going to be a different number pretty much every time, you get 11. Okay? Now, what does 11 mean? That is how many pi sevenths we have, okay? So the coterminal angle is going to be 11 pi sevenths, okay? So that number that you get is your new coefficient of pi sevenths. And that should fall within one positive rotation, okay? Everyone got it? Pretty easy if you do it that way. Take the coefficient of your pi, divide it by twice the denominator, get rid of all those whole numbers, remultiply by that same number, and now you have your new coefficient of pi sevenths. All right, so now that we have 11 pi sevenths, let's see where 11 pi sevenths lives. And we've had this little fun all period long. This will be the last one we do. So here's pi right here. That's the same as 7 pi sevenths. Half of 7 is 3.5. So that's 3.5 pi sevenths. And now we count by 3.5. So, of course, down here, plus another 3.5, we get 10.5 pi sevenths. And then go all the way around, and we get 14 pi sevenths. And now we know exactly where 11 lives, don't we? What quadrant? 4. It goes just past 10.5. So I'm going to draw it a little bit closer to the y-axis. And I'm going to go ahead and write 11 pi sevenths right there at the terminal ray. Now, what is the reference angle? Is it 1/2 pi sevenths? Because that's how far away we are from the y-axis. Would that make a good multiple choice question? Answer? Yeah, answer choice? Yeah, that would be the wrong answer. We want this one here. So how far is it from 11 to 14? Yeah, it's 3. So don't forget, it's not just 3, it's 3 pi sevenths. Okay, so I'll call that alpha sub ref. There you go. That's not too bad. In fact, that's almost enjoyable. Like a trip to Joshua Tree State Park before the government shutdown. It was downright enjoyable. Okay. Yeah, there you go. Okay. Have a good weekend, everybody. Thank you.